Let's take a look at this problem where we are trying to figure out what could the element x be given this Lewis-Dot structure. So we're kind of working backwards. And there could be several possibilities, but we're going to figure out which kind that could be. First of all, let's count the total number of electrons that we have. 2, 4, 6, 8. We have 8 around each chlorine, so I have 3 chlorines. That means that I have a total number of electrons of 24. Okay, out of these 24 electrons, how many do all the chlorines contribute? Well, I know that chlorines contribute 7 valence electrons, and I have 3 chlorines which contribute 7 electrons each, and it gives me 21 electrons that come only from the chlorine. That means that the electrons that come from the element X have to be 24 electrons, minus the electrons that come from the fluorine, or the chlorine, 3 electrons. Okay? So the element that contributes 3 electrons will be in group 3, and typically the one we have talked about is boron. So this molecule would be BCl3, where boron is, we just mentioned it, is the exception to where it does not need a full octet, is happy to have just 6 electrons around it. Let's look at this example here, where we have, once again, we will add up all of the electrons around the total number of electrons. So I have 2, 4, 6, 8 electrons for each chlorine, and that gives me a total number of 16, but then I have 2 lone pairs on this, which gives me 4 more, for a total of, let's see, I said 16 plus 20 electrons altogether. Now let's figure out how many come from the chlorines alone. I have 2 chlorines, which means that I have 2 times 7 apiece, and that gives me 14 electrons that come only from the chlorines. That means that this element X, the number of electrons that come from X, has to be equal to 20 electrons minus 14 that are from the chlorine, and I get 6 electrons. Okay, I have several possibilities. Any of the electrons in group 6, or of the atoms in group 6, can be X. So X can be oxygen, X can be sulfur, so it can be any of those elements in group 6, because they all have 6 electrons to contribute, 6 valence electrons, and therefore I can add either one of these or any of the group 6 elements. Let's look at the last problem here. Once again, let's count the total number of electrons. 2, 4, 6, 8. I have 3 chlorines, which gives me a total of 24, and then the lone pair, a total of 26 electrons. Okay. How many electrons come just from the chlorine? So the chlorine, I have 3 chlorines, which give me 3 times 7 equals 21 electrons. Therefore, the number of electrons that come from X are equal to 26, the total number, minus 21 electrons from the chloride, which give me 5 electrons that belong to my element X. Any of the elements that belong to group 5 will fit this description. So I could say nitrogen or phosphorus or any of the others. So therefore, these can have more than one. You can see the scenario. Now, if I gave you the molar mass of that compound, you should be able to tell me if it's nitrogen NCl3 or PCl3, because you would know by the molar mass. But because I didn't specify any of it, any of these or group 5 elements would fit as the X.